Okay, so for this I'm going to do another example of contingency table. Okay, we already did one example working through the steps of finding the expected value, finding the critical value on the curve. So a lot of it is very similar to what we did in chapter 8 with hypothesis testing and mean and proportion. Okay, so another example. Okay, we have passing high school, pass, fail, and then male and female. Okay, there's times where I'm expected to just be able to look at the table and use some common sense thinking about what could our variables be and what's the table showing us. So we're obviously looking at passing high school, failing high school, and looking versus male versus female. So if I'm writing out my null alternative, and this time it's going to be statements, it's not going to be symbols with values in it. Same concept, but just since there's so many different levels of the variables, I don't want you to write out every single equality into the statements. So I have there's no association with gender and passing high school. The alternative, there is an association between gender and passing high school. Okay, so it's just saying no association, meaning that they are independent from each other. So it doesn't matter male, female. The proportion of how many people pass, how many people fail is going to be about the same no matter which gender. Okay, there is an association, means that there is some kind of relationship. Males have a higher passing or have higher failure depending on the gender that you are. And look at these numbers, they look fairly close, but we're gonna run the test to see if they are or not. Okay, so the first thing I'm gonna do, we have our null and alternative. Now I'm gonna draw my curve and go to my chart and find my critical value. Remember, every curve for the chi-square is going to be skewed to the right, and it's the right tail test. Okay, you need your degrees of freedom. Degrees of freedom is rows minus 1 times columns minus 1, number of rows times the number of columns. So we have 2 minus 1 and 2 minus 1. Degrees of freedom is 1. Okay, so we're going to assume 95%. We have degrees of freedom are 1. If you go to the chart, you should get 3.841. Okay, so that's where we have our reject and our fail to reject area. Now to get our test stat, we first need to find the expected values, and then we have to find each test stat for each cell and add them all up. So if we're looking at this, first thing I want to do is find some totals. So if I do the totals going down and going across, 143, 147, 227, 63, and a grand total of 290. Okay? So find our expected value for each. We are going to do the row total times the column total divided by grand total. Okay, so for each one of these cells, we have to do row total, column total divided by grand total. So I'm not going to do every single one, showing the formula for every one, but I'm going to put I'll put 2 of them up. So if we're doing this first cell here, males and passing, we're going to have 227 times 143 divided by 290. Okay, getting that should give you, I'm on around 3 decimal places, 111.934. Okay, that would be our expected value for that first cell here. Okay, the values we're given are the observed, what we're calculating is expected. Okay, if I'm going down that column, still a male, but now we're looking at failures. So now we're looking at 63 times 143 divided by 290. Okay, so if you find a pattern that you're going through to make this easy for you, that'd be great. Okay, I always go down my columns and do each one. So if I plug this in, 31.066. Okay. So why don't you go ahead, pause it, do the last 2, make sure our numbers match up. Okay. Okay, so there are the other 2 expected values you should get. I have 115.066, 31.934. These are expected values. The observed were already given to us. Now we have to get our test statistic. The test statistic is the observed minus expected squared divided by expected. Okay, so for again, each one of these cells, it does take some time. I would expect to be able to do a 2x2 table on a test or quiz in not too much time. So you do have to get, again, and find the pattern, find that kind of organization to get this done quickly. So again, I'm gonna put two of them up on the board so you see the formula. So again, sticking with that first cell, the observed is 109 minus the 111.943 squared. Okay, so I have the parentheses, I have the square outside the parentheses, divided by 11.943. That should give you about 0.077. Okay, so that's the first test stat. Keep going through with it. I'm gonna go down and get my columns. I go down my columns, that's how I stay organized. So I'm looking at the 34 observed. 34 minus 31.066. Square that, divided by 31.066. This one should give you about 0.277. So just like before, I'd pause it now, do the next two, and make sure our numbers match up. Okay? Okay, so I have 0.075 for the females who passed, 0.270 for the females that failed. And you can see a lot of these numbers are very close to our expected and observed. There's not much different distance between the two. That's why our test scores are fairly low compared to the other example when the numbers were far apart. 29 compared to 31.934, 118 compared to 115.066. Not the biggest difference in the world. So that's why our values are a little small. Now I'm going to take all those blue values and add them up. 0.077, 0.277, 0.075, 0.270. Okay, add all those up and our test stat should be about 0.699. Have a little chi-square symbol there, or if you just want to write test stat to let me know that's what that value is, that'd be good. And now we have to go up to our curve and see where it falls. We have the reject, fail to reject. So if we're looking at that, we see just like a normal number line, 3.841, we're comparing it to 0.699. 0.699 would fall somewhere in that area there, the fail to reject area. So that's what we're on to do. Fail to reject. We have no evidence to say there's an association. Okay, so what we're seeing here is that the proportions are similar to each other. Male, female, very similar to each other. Okay, there's no evidence to say there's a relationship between your gender and if you pass or fail high school. Okay, this would be the work I expect to see on a test or quiz. This would be the work to show me you know where you're getting your expected values from, where you're getting your test stat from, and the degrees of freedom of how you're looking at the chart to get your critical value.